So, Quentin, if you want to start.
All right, thank you. Thank you, Pascal, and thanks for inviting me to join you today. Technology is amazing that we can all join together on these presentations. So, as Pascal said, I'm going to present on XNodes. Hopefully you can see my slides now and everything's going well. I'm with Q Software Innovations. My full-time job, though, is with the U.S. Air Force. I work at Hill Air Force Base in Utah. So I do consulting on the side. So that's how I kind of split my time. I also volunteer. I'm one of the directors at G Central, along with one of your own there, Danny, who invited me to come join you. So everyone calls me Q, and everyone's feel free to call me Q. I got those nicknames for both the Star Trek and James Bond references of that. And so that's a little bit about me. Here's how you can get a hold of me. My avatar on most of the forums is this Zealot guy. LabVIEW Zealot is what I call him. So you can see him there. So an overview, I'm going to first have a little bit of a disclaimer, and then I'm going to talk about the basics of what an XNode is, why I started creating them, and then the rest of my presentation is really about a specific one that I created. And as we go through this, I expect to, have you ask questions and such. A little bit of a caveat beforehand is I'm not really an expert at XNodes. This is the first one I've tried to create. There's probably lots of people that are better at it than I am, but maybe you can see my point of view about why I started trying to make one and just kind of what my learning curve was. So disclaimer first is NI has not opened XNodes up for creation to the general public, even though they are part of the G language, and they are still unofficial to create them. So be cautious in using them in production code. That being said, NI does create XNodes for use. For example, the error ring is an XNode. Match regular expression is actually an XNode. Database variant to data and the time loop data nodes, those are all XNodes. So it's not like this is some unused back of the language feature. This is actually used quite a bit. It's just that NI hasn't opened it up for us to be able to create them. That being said, there is actually a way to create them. So XNodes are basically just a library of a bunch of the ability VIs. For those of you familiar with a XControl, the XControl is kind of the front panel version, whereas an XNode is kind of a block diagram version. You can, with these ability VIs, you can essentially receive events fired from the IDE to have it do certain things. And then ultimately what it ends up creating is a wrapper around some scripted code, what they call the generated code, that then makes it so that is the executable portion of the XNode. All of the rest of the code is all edit time stuff. So like I said, this is not natively open in the LabVIEW IDE. In Windows, it really requires a special license that's only internal to NI to be able to natively create them. If you're on Mac or Linux, though, you can add this to the configuration entry, the XNode development LabVIEW internal tag equals true. So that's how you can create them in Mac or Linux. So
Q, we have our we have our first question. Martin Vernout asks, you mentioned a language feature. It is not an editor extension interaction with the script option at edit time.
I'm not sure if I understand the question.
You mentioned a language feature. It is not an editor extension.
Yeah, it's not really an editor extension because it already comes with LabVIEW. There are ways that you can create these, which I'm going to show in just a minute, even though you don't have the special license internal to NI. So if I'm answering your question right, it's not an extension that you have to install after the fact. It does come natively with LabVIEW. So it's just they don't open it up. But there is backdoor ways to create these, and that's what I'm going to show. Does that answer the question? Hopefully. If not, you can ask a follow-up question. So the backdoor way actually is right on this slide. For Windows, you can use Brian Hoover, aka Huva, his XNode editor from Lava, and I'm going to show that in just a little bit. But before I show the actual editing and what I did, the ability VIs, there's like 51 different abilities. Now, you don't need to know them all. If you want to go to the LabVIEW wiki, you can get a list of all of the abilities and what they do. I put a few of the important ones here. Obviously, state is actually a strict type def control, and that's where you keep all of the state of your XNode, similar to the state control that you have in an X control. Initialize is what gets fired when you first drop your XNode, and so that's how you set up like the initial look of it, how it's connecting to things, that sort of thing. Adapt to inputs is an important one. That's what happens when you wire something into it, if you want it to change the way that it reacts based on how you wired into it. The build menu is what happens when you right click on it. You can have it build a menu on the fly and do special stuff. And then select menu is the corollary to that, where after you make a selection, that's the code that is fired after or based on the selection of the menu. And then ultimately generate code is the scripting code necessary to create what's going to be the code at edit time, or excuse me, what's going to be the code at execution time. So generate code is where you basically create what's going to be the node's operation at execution time. Couple more on operator click. That's just a regular left click, mouse click on the node, where the menu is the right click. Auto tool regions, you can define different regions to have the tool change, the auto tool change. This is really only helpful if they have the if the developer has the auto tool on. And I'll show how I use that here in just a minute. Get bounds, get image, and get terminals. Those three are all to tell essentially LabVIEW how to draw that node on your block diagram. Bounds tells it, the size of it. Image tells what it's going to look like, and then the terminals define not only the data type of the terminals, but where the terminals appear on the node. And so you have to define all of that because you're basically creating your own quote unquote LabVIEW primitive this way. So in edit mode, all of those ability VIs execute in its own context, the nilv.xnode context. And they all get their own clone of it. So if you have multiple nodes, they all have their own clone of all of these ability VIs running in the background. Some of these ability VIs have an output that is basically an array of strings called replies. And what those can do is those can fire other ability VIs, or it can be information back to the IDE. It just depends. Those replies are named states of what to execute next. And then the cool thing is on these XNodes, you write all of this code to show how to tell LabVIEW how to execute the interaction with the developer. And then ultimately, only the generated code is the thing that will run at execution time. So, for example, the error ring has a lot of code to handle the dialog box pop-up, to handle clicking on the error ring to toggle things on and off. And all of that code is in all of those ability VIs. And then ultimately it generates something similar to, you know, can't remember, my mind just went blank, the error dialog, so that it generates that error, or the build error, so it generates that error. And really, in that node, it just acts like a sub VI call. It's calling that generated code just like if it was a sub VI. For debugging, there's this other LabVIEW config that entry that you can put in. It's called XNode Wizard mode equals true, and that provides a special right-click menu option on your XNode that lets you open up the specific clone of that XNode, of that ability of that XNode, so that you can debug that code. And all of the debugging tools work as far as highlight execution, breakpoints, etc., will work in those ability VIs, in the clone of those instance of that XNode. So why did I start creating one? Some of you may know I created a toolkit called the QControl toolkit that allows you to create, very elaborate UI controls similar to an X control, but without all of the hangups and quirks of an X control. And then it allows you to essentially have a class wire that you can handle all of the manipulation of that control. Well, as many of you know, in LabVIEW classes, you can pass a class wire to a property node and view all of the properties of your class, just natively in the property node. Unfortunately, you can't do that with invoke nodes. They never implemented a way to be able to place an invoke node down, wire your class wire into it, and then see all of the methods, excuse me, all of the methods of the class. So I wanted to create something that would allow you to do that, so that in my QControls, you could wire the QControl class wire into, I call it the class method node, and it will allow you to select the methods that are owned by that class. Makes the methods easier to find. So here's a little bit of an overview of what I ended up. So actually, before we move on to what I created, I know I just really briefly covered what XNodes are. Is there any questions anybody wants to ask about the XNodes?
There are no questions in chat at the moment.
Okay.
See nobody typing, so I think you can continue, Q.
Okay, I will continue, but feel free to interrupt if you think of a question that you want to ask. So I created this class method node to act like an invoke node. It accepts class wires, and it also accepts, bioreference classes. In other words, a DVR with a class in it. The node knows the context of the VI it's in. So say the VI is owned by the class, then it will show all of the private methods and everything. If the VI is, not owned by the class, or it's owned by a child, it will show the protected methods. If it's owned by a friend, it will show the community methods. And under any condition, it will show all the public methods. So I'll show that in a minute, but basically, when you click on the class method node, just like when you click on an invoke node, it's going to pop open a menu showing all of the methods that you're allowed to use. And it will only populate that with the ones that you're allowed to use based on the context of the VI it's used in. I also alternatively have a property dialog box that allows you to select class and method besides being able to click on it.
Q, we have another question.
Okay.
The question is, you said the Hoover toolkit for XNode was a backdoor way in, but the NI official way was restricted by a special NI license. Do you know what the differences are between the two? Are there any restrictions?
The difference between the two, which you'll see when I start showing some of my code, is the XNode file appears locked, and you can't see any of the files that exist under it. So none of the ability VIs you can see without having Hoover's tool. If you had the special license, then those, I assume, because I don't have the special license, I assume they would look just like any other library where you would see all of the files underneath it. Another thing that's locked out because we don't have the special license is if you wanted to access any of the properties or methods of the XNode VI server class, those are all locked out. And so it actually takes a little bit more effort to manipulate the XNode itself with VI server. So I assume that if you had the special NI license, that those wouldn't be locked out, and you would be able to see the XNode VI server class and all of the properties and methods of the VI node, or the XNode VI server class.
Okay, thank you. So the question was asked by Tom McMillan. I was notified that it maybe is better when the people ask the question themselves. So if somebody has a question, I will ask you to stop, and then the person can ask a question himself, and then maybe have a small dynamic conversation.
Yeah, that's fine.
Okay.
Yep. Okay, so what my algorithm attempts to do then, after you've selected the class and you've selected the method, it attempts to determine the inputs and outputs of that method. Tries to find where the class in and class out is, where the error in and error out is, and where all the rest of the parameters are. And I have a pretty elaborate algorithm that finds all of these things, but if it can't find all of those things, then it will pop up the configure method dialog, and then you can essentially define which inputs and outputs are class in and class out, which is error in and error out, and which ones are parameters. And then it will also try to determine if it's a constructor, a method, or a destructor. And the way that it does that is it basically says, well, if I don't have a class input, but I have a class output, and I have error wires in and out, or maybe I don't, it actually doesn't care about the error wires, it will say, okay, I must be a constructor because I'm creating a new instance of that class, so I'm making a new object. And then the destructor likewise says, okay, well, I must have an input, but I don't have an output of the class, so I must be a destructor. Now, it really doesn't affect anything, but there's a glyph that changes depending on what type it is, and that's really to help you with documentation. So the glyph on that changes will make it look kind of like a .NET constructor or a .NET destructor, so that you can tell that that's where the class is being constructed and destructed. So impact to executing code. In the generated code, the class method node just acts as a sub VI calling the method that you chose. So really it's a wrapper around the method. And so you could almost take it as, well, why didn't I just call the method directly? I mean, that's still doable. And you have very little execution hit by using this XNode. This just helps you be able to find it and interact with it similar to what you're used to with an invoke node. There's one caveat to that, though, is I also made this, like I said earlier, I mentioned that I made this handle by reference classes. So if you wire a DVR with a class into it, my generate code also generates the wrapper of the in-place element structure to read and write to that DVR. So it automatically writes that in there for you. So the way that this makes it simpler is now you can create, for Bioreference methods, you could create your methods with still having the classes, the input and output. You don't have to try to replace the input and output with the DVR instead. So why use it? Just it makes it easier to find and use methods. And in the case of the Bioreference structure, it takes care of the in-place element structure, DVR reads and writes. Before I go on with the rest of my slides, I'm going to show you my code here. So like I was saying before, Thomas, the class method node right here is showing that it's locked. I can't really modify that, edit it, do anything with it in the context of the LabVIEW project. Just for the sake of ease, though, I've included the main VI in my project of Huva's editor. So I'm going to run the editor. I'm going to come in here. I'm going to say I want to open. Let's see. I need to go find the file. Let's see. Give me just a moment. So I'm in here in my file system, coming down to find the XNode file. So there's the XNode file, and I hit OK. And then this is all of the ability BIs I chose to create for my XNode. And this editor is kind of nice. It basically, if you want to create a new one, you can come select it from the menu, and it has pretty much all of the abilities that are allowed here. As you can see, some of these are numbered. That's because they've deprecated old ones. And so I recommend, if you're playing around with this, select the highest numbered one. But they leave them in here because they want to have any XNodes they've created, meaning NI's created, be backwards compatible. So they're all still there. And I don't know 100% the difference between all of them. I've just used the most recent one, the highest numbered one, and everything's worked for me. So if you look, some of the more important things I have are like the state, adapting to input, what it looks like on initialize. Some of these like terminal, if you double click on these, it opens the BI so that you can look at it. Say some of these like get terminals, I'm just reading the current state of the terminals from my state cluster. But how I populate those, well, here's just a look at my state cluster. It ends up being pretty big because I have like the class properties and stuff. I have all the methods that could be in there. I have the selected method, and then I have the terminal information. And this terminal information is a strict type def cluster. Well, I guess not strict, but it's a type def cluster that meaning NI's defined. So this is what defines where the terminals get drawn. If I come in here to adapt inputs, this is what happens when when someone wires something into my XNode. And so this is one thing I was talking about as far as getting the properties and methods of the VI server XNode class. I had to do some tricky things with this in order to get this to show up. You can, here I'm gonna just, let's see, locked, I gotta unlock it for editing. You can like come in here and say, all right, I wanna select the class, go to the VI server, let's see, it's in generic, GObject, node, but you see that there's no XNode in here. And so you end up having to select node, just have node properties, because like the owning VI is actually a generic class property, and then wire this into it. And then it will work. If you just try to select on here, because I'm locked out, because I don't have the license, it just says there's no properties and you can't do anything with it when it's already wired to the XNode. So just an example of some of the hoops I had to jump through, besides using Huva's toolkit. But this basically comes in, what ends up showing up in these term types. This is an array of the data type and kind of an ID of all of the terminals that are wired. And so I come in here and I do some fancy stuff. Oops, I didn't mean to close the VI. I do some fancy stuff where I determine if what was wired to it was a class using the variant attributes or the variant data type VIs. And I determine if it's a class or if it's a DVR with a class in it, and then I determine what class path is and add that to my state data. And then ultimately I figure out the terminals and I end up drawing, let's see, I believe it's in here. I get all the method info and then I draw the node. And so, oops, I'm looking at the wrong screen here. So I get all the methods and get the method info, and then I draw the node and I put, this is the code to draw the node. Basically it draws it and puts the image in my state. And then this is the replies back saying I want LabVIEW to update the label, I want it to update the terminals, I want it to update the image and bounds, and I want it to generate the code. So it goes through in order and executes some of the other abilities. And ultimately, like I said, with the terminals, the image one is just the same. It just is getting the current image and outputting it. And then the generate code is the heavy lifting part that takes the selected method and the selected class, determines all the connections, and then decides if it needs to generate just the method wrapper or if it needs to generate the in-place element as well. And I mean, I could show you all this code, but it's just, like you probably know, scripting code ends up being very long and verbose just because of all the all of the properties and methods you have to access to do it. So I can show you more of the abilities, but before I go further on that, I'm going to show you what this actually looks like. So if I go into, let's see, I have it in test VI here. So I have just a basic VI. I have a couple of them here, a couple of my class method nodes. If I come in here and I wire my test class into it, then it says, okay, I have my by value test class, and I can click on this and I can select which VI, which method I want. So like I can do the dynamic ones or the static ones. I mean, these probably aren't very interesting because I just have basic stuff in here. But some of the more interesting ones is like the constructor. It says, oh, I'm a constructor, I don't need this wire. And so now it knows that it's creating a new instance of that class. And then I can go on and select, the other methods that it's doing. And oops, that one doesn't have an output. Let's select one with an output. Standard. And then let's select the destructor. So there's my destructor. And if I want to make it actually reflect that it's a destructor, I can click and toggle this glyph so that it shows that it's a destructor. Really, the glyph has no functional significance, really, just meaning it doesn't change what's being scripted. It's just for documentation purposes. So I can change it to make it look like it's a constructor and destructor. Then, like I was saying back in my presentation on the slides, by adding the debug tag in my INI file, it creates, let's see, you know what? I might not have it in, since I reinstalled LabVIEW, I don't have it in there. I will go put it in there real quick and we'll restart LabVIEW. Sorry about that.
So in the meanwhile, Q, I have another question from Bas van Etten.
Okay.
So you've created this to look like a regular invoke/constructor node? Like you made this on your own, the way it looks, or did you just grab something that I made?
No, I had to program the code to have it create the drawing the way that it looks in order to have it draw it the way that I wanted it to come out. So yeah, I ended up basically writing all of that drawing code.
Okay, so it's not just an image. You programmed how you want it to look like.
Mm-hmm.
Okay,
I did.
Is there a way you're willing to share this?
Yeah, I will share it with you. Give me just a second to get that tag in.
Yeah, sure.
Sorry that I had to do this while we were presenting. I didn't realize I didn't have that in already.
That's no problem. Take your time.
So
I also have a question. So when you are using class wires and you wire a child class to a parent method, the parent method will switch to the child class instance of that method if it is available. Does
yes.
Is this functionality also supported?
Yes, because of the wiring, it knows to rescript itself, and it will rescript itself based on that based on that new class, the child class that you just wired in. If it was already selected that it was the parent, it will go find the child and replace it with the child. If there isn't a child, meaning the child didn't override that method, it will still call just the parent's method.
Very nice, very nice.
Okay, I do have this in now. Let's make sure it will show up. So I guess while you're seeing right now is my shot of the LabVIEW wiki, and this is all of the abilities, and you can click on these and there's a page for each one describing what it does and such. In the editor, it also has that. So Brian Hoover wrote the most of the wiki pages too, so they're pretty much the same text. So here, I'll open the XNode again. So like if you come in here and say, what does build menu 5 do? This has description of it. So, okay, now that I have that tag in my INI file, I should be able to show you the debug. So let me get to the VI that has my XNode init. And I didn't end up saving it from last time, but that's okay. So now if I right click on this, you can see some of the stuff that I generate and put in here from the menu. But this is what I was wanting to show you, this XNode Wizard menu. This will let me open up the abilities that are running for this instance that I right-clicked on of that XNode. And so I can see what, you know, it's doing as I'm debugging. I can also see what it generated. So I can come in here and say, show me what code got generated. And so here's the code that got generated. And really it's just the inputs and outputs and a direct call to the method that I selected. And what's cool is sometimes it doesn't always work. I'm going to try it though. So this might be a crazy experiment to do in the middle of a presentation. But if you select the VIC, you can see that this is the child class version. And I have the child and the child and the parent methods here. I'm just going to select this non-standard one. This non-standard one is showing that all of the connectors are not in like the standard location. And there it shows it. So it's all messed up, but it still connected everything to where it needed to connect it to. And this guy still looks the same. So if for some reason they put the class wires in weird places and the error wires in weird places, my algorithm goes and tries to find them anyway. So to answer your other question about the drawing code, so in here, let's see, let me close this so that it's not locked. So these are all my sub-VIs that are in the various ability VIs. And I have my drawing node code here. And so the top level is to draw the method node. And so this handles, you know, what the text is, drawing the banner, drawing the, you know, the class banner, drawing the method, drawing the parameters, all of this stuff. And let's see, I don't think it will, well, it might run on its own. Let's see. Yeah, it just creates just the generic thing though. I do have some unit tests that I created using Karaya, and I do have a test for drawing all of the different various nodes. I don't know how well this is going to come out, but essentially it's testing it against the drawing. Here, I'm going to just try probing this and just let it do its thing. Let's see. So on the probe, you can see that it drew basically this first one, and then with other parameters and stuff set, it drew the second one with the constructor, and then it drew one with the destructor, and so on. Does that make sense? So yeah, I end up actually drawing all of these things out. If I go deep dive into this, just on one of the VIs, like doing the banner, let's see. Here's my code that's actually, you know, drawing boxes and filling and deciding if it needs to draw the cube or if it needs to draw, you know, the constructor glyph or the destructor glyph or the method arrow glyph. And this is for the errors, the input and output errors. This is for the input and output class glyph.
So Q, I'm curious, do you use bitmap images, or are you drawing everything using the the native functions?
I chose to draw everything with the native functions.
Wow.
But yeah, you could, I mean, because they're so simple, but I could have done it with the native images. The reason why I didn't is because at first I was thinking that I wanted the class banner portion to show the class color. And so in here on my draw node code, I actually have this class banner color. And so it will draw it with whatever color I want. Right now I have it hard-coded to the kind of light yellow color, so that it will always draw with the light yellow color. But at first I was thinking to have it go determine what the class's banner's color is, and then have it draw it that way. That still might be an option to do in the future because I have that option here, but I took that out because I figured property nodes don't do that, so why should this change color too? So anyway, does that make sense?
Yes, that's amazing. Thank you.
You're welcome. All right, let's get back to the slides. And then, so there's a few final words. There's a couple of problems with this class method node, and I can't figure out how to circumvent these problems. One is if the method, so you've already got a class method node with an assigned class and an assigned method in it. And then you go edit that method and change the connector pane of that method. Your class method node isn't going to automatically rescript and change. And it's okay in a way that it's okay if, like, you change from a numeric to a string or something, then it's going to break and it's going to show up as an error in the error window that there is a problem with the class method node. And then you have to go basically select a different method and then reselect the method to get it to rescript it with that new connector pane setup. One more insidious problem, though, is let's say you didn't change it from a number to a string, you changed it from a U32 to a double. Well, then it's not going to show up as broken. It's just going to coerce the data type. And so this could be a problem if for some reason that causes problems in your code, in your method. So if I can figure out a way that changing the connector pane of the method that's wrapped up in this causes the class method node to rescript, it would fix that problem.
Q, we have another question from Danielle.
Okay.
Will it show a coercion dot?
It won't show it on the class method node. If you go look at the generated code, it will show it there, obviously. You know, there might be a way that I could force it to show a coercion dot on the class method node itself, but I'd have to go check to see if the terminal has a coercion dot and then draw it myself, which means something would have to invoke that behavior to happen. And that's the problem I'm having, is when the method changes, there's nothing that invokes the XNode to do anything. There's no feedback of that event. So I guess that was kind of a long answer for a short question. The short answer is no, it won't automatically show that. It won't automatically show the coercion dot.
It would be cool if that event was exposed in LabVIEW.
Yeah. Now there is, let's see, going back to the project and to the editor, there is a ability called onRefE change. And one of the things you're supposed to be able to register for is that, and then the refE is what you're calling, basically, the method that you're calling. One of the things that you should be able to do is say when the refE's connector pane changes. But I played around with that a little bit and couldn't figure out how to get it to work. And I went on Lava to see how you mess with the Refi stuff. And what I ended up finding was an article from Stephen Loftus Mercer saying don't mess with those. So I decided not to mess with them. But if someone at NI took my class method node and could make that part of it work, then this would be, what I would think 100% complete. But right now it's like 99% complete. So just to end things, I have a summary of links. This is the Lava link that you can find the Huva's XNode editor. There's a lot of XNode pages on the LabVIEW wiki. Currently, I have it open, so you can go and do a fork off of my GitLab repo for the class method node and play around with it. I haven't yet published it to VIPM. If I do, it probably will be published in kind of a beta state because of those weird caveats that you have to be aware of. If those get fixed, or if anybody out there that's listening to this knows how to fix those and can help me, that would be awesome to figure out how to use those on Refi change stuff so that we can not have that problem. And then, like I said, the whole reason why I started this was to make it so that it was easier to find the methods of your QControls. If you want to learn more about the QControls, you can download it for the kit from VIPM.io, and there's actually a lot of videos. I did a presentation at NI Week, and that link is on the VIPM.io page. There's also more information on the wiki, and there's also an NI forum called the QControl Enthusiasts, and I monitor that a lot. So if you start playing around with these and have questions, that's probably the best place to ask questions, is on the QControl Enthusiast page. And I'll answer it there so that others can find it too. And then just last but not least, here's all of the G community links. A lot of them I'm involved in. Like I said, I'm involved in G Central. I'm one of the admins for the LabVIEW wiki. And so I get my fingers in a lot of things. So other than that, that's all I have. I'll go ahead and take any other questions.
So if people have questions, now is the time to ask them in chat. We get a few thank yous for you, Q.
Thank you.
Roger has a question.
Yeah. Quentin, how much time did it take to this XNode?
Well, this was my first one, so there was some learning curve to it. I would probably say on the order of 40 hours, maybe 40 to 100 hours, something like that. I don't know. Yeah, just I had to learn how to do it as I went and learn what all of these abilities did as I went. So
it's also a really, really complex first version, I think. At first, if you try, you already have a very yeah,
that's true. I could have started a lot simpler on creating my first XNode. I know that Huva created one that was pretty cool. It was a logic table where you could put in multiple trues and falses, and it would, do more complicated ands and ors of the logic table. That probably would have been an easier start than trying to deal with all of these classes and DBR data types. But this is what I was trying to solve. I had an actual problem I was trying to solve. So that's why I went the way I did.
Oh, I know. Yeah. That's also driving you, eh? The fact that it's, you want something solved.
Exactly. Yep.
Nice code.
So
you.
Maarten Scharion has also a question for you.
Okay.
Yeah, so I was wondering, do you know of, like, I think we cannot see the inside of a nice XNode, but do you know maybe other people that already have examples of it that you know of that created these XNodes?
There are several on Lava. I know that, like I said, Brian Hoover has posted several of the ones that he's made, and you can go look at them. Kind of interestingly enough, after I put on that that tag, I could come in here and look at like the air ring, put one of these down, and there's the XNode Wizard, and I can see all of the ability VIs for the ring. Now, because it's NI, some of these are password protected, and so you can't actually see what's happening in them, but some of them aren't. And so I was able to kind of look around in some of these and see what they did.
Yeah, I could be indeed inclined to say that that's pretty interesting also to learn from what NI already did with some of their existing XNodes. So this is indeed a nice caveat to actually see a bit inside them as far as we can.
Another one is
nice.
this match regular expression. And so it's an XNode too. So you can see their ability VIs with that one as well.
Yes, very nice. Thank you.
You're welcome.
Okay, no more questions, I think.